students. Today's problem is not so difficult, but you have to exercise the exception handling today. So you have learned what is an exception and how to handle it. So can anybody tell me what is an exception? Is it a good state or a bad state? Bad state. That's correct. So it is an erroneous status, but it can be differentiated to other kinds of errors in the respect that it can be captured, it can be detected. So once it is detected, you may handle it. So the detection is an important problem for most of time in programming, but in using exception, you can handle such kind of cases. For example, think about that you have a number n, but n should be divided by another number m, but m is, think of that m becomes 0. Then the operation division cannot be performed. So in such cases, your compiler may raise an exception, your computer may raise an exception, and you can write a code to handle it. So some guys may ask me that, then why should you check m before the division? So that is a good question. So it is possible to prevent such kind of erroneous cases by checking extensively. That approach is adopted in C. So in C, you have assert. So for the division case, you may assert m should not be 0, and then you may perform the division by s equals n divided by m. Okay, so when the assertion fails, so if it happens to be m equals 0, so the assertion failed message is raised and your program is just blew up. So that is an approach of assert. But in C++, it goes, you also have an assert, but you are having an exception. So the exception, you don't have to check it before the division. You just make a division, and that you may try this, and you may catch that exception, catch some kind of exception, and that is handled here. Okay, that is another approach. So let them go, but once an error is detected, once an exception is detected, you'd like to handle it. So that kind of exception handling method is called exception handling. So you may try this. So the one good point of this exception handling mechanism is that you can separate the normal control flow. This is normal control flow with exceptional control flow. You know that this is an exceptional control flow. They are separated. But your exception may raise some place, and your exception can be handled in another place. So you have to transfer that exception to the handling point. That is called an exception propagation. So you have to think about the call stack for that. For example, your main function is calling another method. And you have a caller-caller relationship. Your main is called a caller, and this method 1 can be considered as a callee in this function call. And that also holds for another function call, such as method 1 may call method 2, and with the respect of this call, your method 1 is a caller in that case, and method 2 is callee. So your method call or function call can be nested arbitrarily. So they are stored into stack. So this kind of stack of method calls or function calls is called a control stack, or sometimes it is called a call stack or control stack. But think about that. Your final call may be method 3 from method 2, and there is an error. There is an error. Exception is thrown here. Exception is thrown. Exception is thrown here. But it may be handled in method 3, but there's no catchy clause. It should be transferred to method 2, since it is abolished. But if your method 2 does not have a handler yet, then it should be transferred to method 1. So the exception should be transferred to the reverse order of the call until the proper catch method is found. So that is called an exception propagation. So the exception is transferred until the proper handler is encountered. So what to learn today is an exception propagation. So you are transferring an exception, just like passing an argument. So the exception is transferred. And exception specification is that you'd like to ensure that a certain code may raise an exception. So that is called an exception specification. And in C++, you are using a throw keyword for throwing exception and for the exception specification. Know that how to throw them. Exception raise. So the throw command is used for exception raise, and it is also used in exception specification. So how is an exception propagated? If an exception is not handled in a certain method, a certain function, it should be transferred to the caller. And the callee stack is abolished. So you have to make an exception object, and that should not be abolished, even though the cause of the exception may be local. The exception object is not local anymore. For instance, if readInst does not handle an exception, readInst may raise a size error, may raise a memory allocation error. It is transferred to main. So how the stack is managed is an important problem. So once an exception is transferred to the caller, the control stack portion, it is a jargon of a programming, which is an activation record. That portion of the control stack is called an activation record. So if you have a main, and the activation record is recording all the local variables of main, so this is called an activation record. Lecture note is not uploaded. Sorry, I have to upload it, but let me just upload it without any comment. Slide. Exception propagation. And after that, I may revise it. C++. Okay, it is loading now. Thank you, Sang-ho. Okay, so you have to when your main function is calling read-ins, the read-ins local variables may be larger than main. Then the activation record size may be bigger than main read-ins. So this is an activation record of read-ins. But once an exception is raised here, this should be abolished. So the call is popped and abolished. Therefore, you need to perform bookkeeping job inside the curly. So please handle it when the activation record is alive. Okay. So in Java, you have a finally block for the bookkeeping job, but in C++, there's no such finally block in Java. So you have to handle them manually. So think about that. Your reading is throwing a size error. Once the size is less than 1, and you know that there's no try. Try is not. And there's no catch. Okay, so exception is thrown from read-ins. And that try catch exists inside of your main, and in your main read-ins is abolishing the their activation record, but the exception may be transferred to as size error or bad or log. So the exception raised in read-ins is propagated to main. So that is called exception propagation. So should I try this? Read-ins. So you have read-ins. Let's see here. In the previous version, you have attached a try-catch block inside of read-ins. Okay, but you may delete this try, and these catch blocks attach it to main. And the main is trying. So raise the exception here, size error, or in your new operator is transferred from your read-ins to try. Okay, so let me just check it. Make read-ins, executing read-ins, and you'd like to enter negative size such as -1, wrong size. So it is handled from your main catch block here. Okay, so if you want to supply a lots of readings, lots of integer numbers such as 3 million, it seems fine. It seems fine here. Okay, so how about readings 3 billion? It works. It's working. Wow, nice computer. How about 5 billion? It works. So how about 10 million out of memory? So your exception is handled for 10 billion, okay? So this is one way to check the exception handling. But let me just exemplify the assertion. So you may include C assert. So in that case, rather than this row, you may want to assert the size should be greater than 0. So this should be the expected case. Okay, so let me just compile this. Readings. So if you enter 0, then assertion is failed since size is 0, but 0 is not greater than 0. So the assertion is failed and your dirty core is dumped. Can you see the readings.exe stack dump, not core dump? Stack dump is dumped. So actually the core dump means that the contents of your memory is dumped as a file to help you debug your code. So you can check that the assertion can be used here, but the method is very ugly, so it is better to use exception handling. Okay. Any questions up here? No questions? So let's go back to the slideshow. So the exception is transferred from your readings to main. And exception specification is that you may want to specify my function is throwing some kind of exception. So this is important for the robustness of your code. So if your code if your function has or method has this kind of clauses at the end of its function header, so it means your function may throw an exception 1 or exception 2 or some other exceptions specified in ... So if the function has a separate prototype declaration, the exception specification should also be included in the prototype. For example, in your readings, you know that your readings is raising a size error or may raise a bad error because of a new, then you may specify readings throw size error and bad error. It means not always, but sometimes. And there is a special function which is called unexpected. This is a special function that occurs when the exception specification is violated. So let me just check the exception specification in your code. So where is my, okay. So in your readings, you know that your readings may throw some kind of exceptions. So it may throw size error, bad error is thrown from your readings. Okay. So make readings dynamic specification are deprecated in C++ 11. Okay, so it is a deprecated feature in C++ 11. Anyway, it is those readings. So if you want to allocate it 10 billion, it works fine. But if you'd like to throw another kind of error, if size is greater than 100, you may throw another exception, such as, let me just class bound error. This is just an error case. And you know that the exception specification is violated. So you may try to make readings and you'd like to make it readings and 200, which will violate the size upper bound, and bound error should be thrown. Okay, so terminated the call after throwing the instance of bound error because it should be handled, in this case, it should be handled with this exception class, but it is terminated. It is not. Okay, so for that case, you have to use public exception. Then it should be handled with that. Make readings 200. Okay, but it is terminated by readings because it is not handled properly with the main, because your readings does not specify the bound error. So if you want to specify bound error here, then it should be caught by the third catchphrase here, catch clause here. Readings right? Can you see that error is printed as the exception? So it was found here. It was found here. Okay. Any questions up here? No questions? Then I'd like to switch to the today's problem, which is map. We just reshare the code, reshare the screen. So today's problem is map. It is for exercise in handling exception. Exceptions can be raised through using throw command. To handle exceptions, you should use try-catch clauses. Exceptions can be used in various circumstances, such as constructing objects or allocating variables. So in this simple case, include IOStream, try main, and you're reading to integers. And if y equals 0 through y, because you'd like to try divide x by y. Okay, so the y is thrown here. It is caught, since the type of y is just an integer, it is caught by catch int n operator, arrow on operand, n is printed here. So I just use std, std, std just for exemplification, just for instructions. So if you want to use the shown name, then you may want to using namespace. So let me check it from your terminal. So let me just close this into the CPP. Include IOStream. You want to using std main And you know that try is the outermost block. So you may try here. X equals 0, y equals 0. And from Cin you want to read x and y. If y equals 0, you may throw y. C out x divided by y equals x divided by 1 line. This was catch and C out operand. Integer 5 divided by 2 is 2. 5 divided by 0. Error on operand 0. But you may ask that if you try to check this, why should we use exception? So if you really think that, you may include exception. Then this should be totally erased. And your exception can be caught by exception E with C out, non-exception. Try to print E dot what. So let me try this. And if you want to 5, 0, and you know that floating point exception is printed So do you have any questions here? No questions? Then this is the end of today's lecture. Thank you.